So when we talk about alkyne hydrogenation, alkyne hydrogenation is extremely similar to alkene hydrogenation. In fact, not only do we use the same reaction conditions, but we also essentially have the same mechanism. So in an alkyne hydrogenation, just like we do in an alkene hydrogenation, we start by adding hydrogen and palladium on carbon. And that will convert our alkyne specifically into a cis alkene. If you remember from hydrogenation of alkenes, we said that because of the way the reaction's mechanism works, that the two hydrogens always add from the same side of the molecule. And so we see the same thing in alkyne hydrogenation. The two hydrogens add from the same side, and we end up with the cis alkene. But our reaction's not done here, because these conditions are the exact same conditions that we know hydrogenate alkenes. And so this will just react again to give the alkane. And so we've added two hydrogens to each carbon and converted it all the way to the alkane. Now, in this reaction, we're not able to control whether the reaction stops at the alkene or not. It's always going to go to the alkane. And the reason for that is, first of all, the palladium on carbon is catalytic, so you don't really have control over how much of that you have present. But also, you can't really add very easily a stoichiometric amount of hydrogen and say I'm only going to add the exact amount of hydrogen I need to react once. So if you want your hydrogenation to stop at the alkene, we will later talk about other reactions which allow us to do that, but this reaction doesn't allow for that. Just like the alkene reaction, credit for this reaction goes to Sabatier back in the late 1800s. And the mechanism for this reaction is virtually identical to the alkene hydrogenation. So we have our palladium surface here, or whatever metal we decide to use, and the alkyne coordinates to it, as does the hydrogen. One of the hydrogens adds to the alkyne, as it did for the alkenes, and then the other one adds as well. It's this attraction to the surface of the metal that again is what forces the two hydrogens to come in on the same side. From here, the mechanism for the alkene hydrogenation is what we learned previously for how alkenes work, but it's also exactly the same as the alkyne hydrogenation. We can look at some additional examples. But again, pretty straightforward reaction. Regardless of what we do, the alkyne, and it can be terminal, it can be internal, but that alkyne will get reduced all the way to the alkane.